to introduce James. I don't know how many people were here last week for Ariel Waldman's talk on the future of human space travel. There are a few in here, great. So this is a really interesting talk in the wake of that, because Ariel was talking about how we're going out into the universe, about the technology, the machines that we need to build to go out and explore further outward. What James's book and the people he documents in Deep are finding things deeper within this planet, finding things below, and actually not just using technology, but actually finding things within themselves to be able to explore deeper into this planet. So we've got an amazing hour in front of us. Let's give a big round of applause to James to get that started.
Thanks a lot. About 10 years ago, my friend Steve called me up and said, hey man, do you want to go to this lecture? Some astronaut's going to be speaking about how an asteroid's going to hit the Earth and we're all going to die. And I thought, awesome, astronauts, asteroids, space, post-apocalyptic prophecies, I'm in. That was one of the first ever Long Now seminars. It was right over there in the Presidio. And since then, I've been to literally dozens and dozens of these things. So it's really thrilling for me to be here and giving you all my own personal post-apocalyptic prophecy tonight. So I'm going to give you a little review on what you're going to be seeing here. About 2.5 years ago, I was sent by Outside Magazine to cover something called the World Freediving Championships. Now, this is a very weird competition where people test each other to see how deep they can dive on a single breath of air. And I didn't know too much about freediving, hadn't done it, didn't know anyone who had. I remember being out there in Greece. It was held in the deep waters in Kalamata, Greece, outside of the marina, and being on this platform and watching this guy take a single breath of air, upturning his body, and sinking some more, and sinking some more until I couldn't see him. 4 minutes later, he came back up. He had just swum 335 feet on one breath of air. Now, I thought it was totally impossible. I had no idea the human body was capable of diving to such depths. So for a minute, I thought, wow, there must be an air tank down there. So I checked that out online and found if there had been an air tank and if he would have actually breathed some of that air, his lungs would have exploded as he ascended to the shallower depths. He would have died. It's only the human body in its natural form can we withstand a fast 300-foot underwater ascent. So I started checking out some more information and found out that not only do humans share these amphibious reflexes with whales, dolphins, and other marine mammals, but we also share a number of other extra senses with these animals that help them navigate through a dark, cold environment. Humans have those too. That's what I ended up writing this book about, and that's what the rest of this presentation is about. So the second we put our faces in water, something amazing happens. Your heart rate starts to lower about 25% of its normal resting rate. Blood starts rushing from your extremities into your core. Your brain waves soften. You enter this very meditative state. The deeper you go into the water, these reflexes will react more and more until at very deep depths, you resemble only a passing resemblance to your terrestrial form. Scientists call this transformation the mammalian dive reflex, or more lyrically, the master switch of life, and they've been researching it for about 50 years. And the term master switch of life describes not one, but many reflexes that affect the brain, lungs, and other organs that work in concert with a bunch of other reflexes and senses within us to protect us from the immense underwater pressure of a deep dive. They essentially turn us into deep sea diving animals. Now, ancient cultures knew all about the master switch and used it for centuries to harvest sponges, pearls, and food thousands or hundreds of feet below the ocean surface. Certain sailors that went out to the South Pacific and Japan reported seeing divers dive down about 150 feet and stay down there for 15 minutes at a time on a single breath. Now, I know what you're thinking. That sounds totally impossible. And all of the scientists that heard these reports considered them either fallacious or complete exaggerations. They didn't believe them. Even up until the 1950s, scientists said the deepest a human could dive in the water and survive was about 100 feet. Any deeper and our lungs would collapse. Well, today, freedivers are diving to depths of 700 feet on a single breath of air. And the longest breath hold underwater is 12 minutes and 30 seconds. So that's just 2.5 minutes short of these made-up reports by these ancient sailors. And consider we haven't been doing this for that long. Competitive diving has really only been going on for about 15 years. So in a matter of years, maybe 5, maybe 7, maybe even sooner, we'll be diving down to 1,000 feet and holding our breath for over 15 minutes. Now, I know what you're thinking. How is that possible? How can the human body survive in depths that are 30 times that of the surface? Well, in water, the deeper we go, the more pressure increases and the more air contracts. Seawater is 800 times denser than air, so this pressure increase happens very quickly. A dive down just to 10 feet is equivalent to diving down an atmosphere 10,000 feet. Instead of a bag of chips, when you're driving up to the mountains or boarding a plane, a bag of chips will inflate. Well, everything in the ocean deflates the lower and lower you go, even human lungs. So human lungs at 33 feet will be half their volume. At 66 feet, they will be a third of their volume. At 99 feet, a quarter of their volume, and on and on and on. So you can imagine how small they would be at 300 feet. The equivalent pressures of a deep dive down to those depths would probably injure or kill us, but not in the ocean, because we all came from the ocean, and each of us literally has an ocean within us. Human blood holds about a 98% similar chemical composition to seawater. We're only missing a molecule of iron. Seawater is missing a molecule of magnesium. The human fetus, seen here, develops in an amniotic fluid that's about 99% similar to seawater. And our first characteristics are fish-like. We grow fins first instead of feet, and are one misfiring gene away from growing fins instead of feet or hands. We're born to dive. The human infant, when placed in water, can hold his or her breath comfortably for about 45 seconds at a time. And she'll begin breaststroking like this little person and open her eyes, and they're very comfortable in water. And we only lose this ability when we're taught how to walk. But regaining it, as you will soon see, is pretty easy. What I'm going to show you now is a free dive by a French diver named Guilherme Neri. This has been viewed about 20 million times on YouTube. So the second Neri goes in the water, something amazing happens. His heart rate is going to lower, blood is going to start rushing from his extremities, he's going to enter this very mellow space. At around 35 feet, that's where he is now, he's going to enter something called neutral buoyancy, where the water is no longer going to be pushing him up towards the surface as it would in a swimming pool, but it's going to start sucking him down deeper and deeper, and will keep sucking him down. This video is supposed to be in real time, so if you get bored during this talk, you can try to hold your breath as long as he's going to right now. So you're going to see he's going to hop off this cliff here, and he's not going to kick his legs, he's not going to move his arms, he's just going to effortlessly float down. This isn't a video trick. This is what happens at this depth. This is something freedivers call the doorway to the deep, where everything reverses, everything changes. At around 150 feet, his lungs will be about the size of 2 baseballs, and his heart rate will lower even more. Freedivers have recorded heart rates as low as 14 beats per minute. That's about a third of a person in a coma. And some freedivers have recorded heart rates as low as 7 beats per minute. Now, according to our understanding of human physiology, that's totally impossible. that shouldn't be able to support consciousness, and yet deep in the ocean it does, and still no one knows exactly how. So he's approaching about 300 feet, and this is when the master switch really starts kicking in. Blood is going to start passing through his organs, and the alveoli in his lungs will engorge with blood to keep them from collapsing. These reflexes only happen in deep water. That's the only way to trigger them, and we all have them. So his body isn't really anything special. All our bodies would be doing the same thing his is doing at this depth. So as he dives even deeper, something called the spleen release happens. This usually only happens during times of shock. When you get in an accident, the body reflexively releases new oxygenated blood into the bloodstream, but it also happens in deep diving. And freedivers like Neri use this as a turbocharge to dive even deeper. So he's reached the very bottom. Now is the really hard part. He needs to make it back up and still be conscious. But you can see he's very experienced at what he's doing. He is French, so he's doing a little French miming here for you. He's in the invisible box, and he's back up. And since the ocean is pushing against him, he can literally crawl up this cliff as though he were crawling up it in regular air. It just takes a lot longer. As he continues to go up, all of those master switches within him are reversing. So his mind will wake up, his heart rate will speed up, all of the blood within his core will begin pushing out to his extremities. The human body in its natural form can't get the bends when you're diving on your own power. That only happens to scuba divers. We know how to process that exchange of nitrogen gas. As you see, as he approaches, he's going to purge all that nitrogen gas from his body, take a big, deep breath, and get ready to do it over again. So that is the master switch of life. We are not the only ones to have the master switch. Many marine mammals also have it. Seals, dolphins, whales use the master switch to dive to depths much deeper than we can. This guy, the Weddell seal, can dive down 2,500 feet and hold his breath for 60 minutes at a time. Now, researchers who were studying these seals in the 60s found that they actually seemed to gain oxygen the deeper they dove. Now, everything we know about physics and mammal physiology says that's impossible. They can't gain oxygen. These guys don't really care about our rules. They do it all the time. They come up perfectly healthy, and they've probably been doing it for about 100,000 years. So we have more in common than just the master switch with oceanic animals. We also share many of these extra senses that I was talking about. To survive in a lightless, cold, and pressurized environment, animals need extra senses to navigate, communicate, and see. What good are eyes when you're in complete blackness all the time? You need another way of getting around. In humans, many of these senses are latent and mostly unused, but that doesn't mean they've gone away. We still have them, and with a little practice, we can re-engage them. The first of these I'm going to talk about is magnetoreception. Now, we've been taught that animals have 5 senses with which we can view the world or perceive the world: taste, touch, smell, sight, and hearing. But the problem is, in a trackless ocean, what good is sight, again, when you're cruising around, migrating from one island thousands of miles away and back again? It's of no use. So they have to be using something else. And researchers in the 60s were wondering how these animals were able to migrate in these amazing patterns, and they started putting satellite transmitters on sharks. What they found was amazing. Sharks were migrating hundreds of miles from one island to the other and back again. But what was even more amazing is they were doing so in perfectly straight lines, which is a really hard thing to do when you're dealing with ocean currents and you're not able to see anything. So at the same time that marine researchers were looking at these sharks and wondering what was going on, a German zoologist by the name of Friedrich Merkel started noticing some pretty peculiar behavior with European robins. This is a European robin. He noticed that in the fall, the robins always hopped south. In the spring, they always hop north. So even in enclosed rooms, when they couldn't access the sun or the stars, they would always hop in these directions. So Merkel did what many good scientists before him have done, and he started running some pretty weird experiments. He got each of these European robins, got a bunch of them, put them in a bucket, turned the bucket upside down, and on the floor of that bucket was a little touch-sensitive pad that would record what direction the robins would be facing inside of this bucket, where obviously it was pitch black. He did this over several months, and the results were always the same. In spring, they would always be facing north. In fall, they would always be facing south. In other words, this was the exact same direction the robins would be flying in during their normal migration patterns. They were hardwired to be facing in these directions. And they always face in these directions with one exception. When he put the robins in a magnetically shielded chamber, this is what happened to their sense of hopping and their sense of direction. It totally disappeared. So what was interesting is the scientists that saw Merkel's studies and talked to him about it thought he was a complete fraud. They said, this is pseudoscience. They called his studies a complete sham. 20 years later, what did we discover? That not only birds, but a host of other animals, like even bacteria, has a magnetoreceptive sense. So Merkel was right. Researchers believe that all of these animals are able to home in on the subtle energy, the Earth's magnetic field, which is pictured here. And they're able to use this energy as a kind of natural GPS to find their way around the globe. I actually just got this tattooed to my back a couple of days ago, just to remind me. So now I'm going to show you something else. In 2003, I believe it was, some researchers attached a satellite tag to a great white shark named Nicole. 3 months later, this tag came off, and the researchers uploaded all the data, and they were able to see where Nicole swam, how far, how deep, and all that. What they found was amazing. Nicole swam 7,000 miles within 3 months. That's pretty good. But what was even more amazing is she followed a straight line from South Africa to Australia. And 6 months after that, the researchers were in South Africa at the exact same beach where they had tagged Nicole. And who did they see? Nicole. She had swam back, probably following that same tract. So how is this possible? Many researchers believe that these little dots on the shark's nose have something to do with it. These are called the ampullae of Lorenzini, and sharks have about 1,500 of these, and they're sensitive to the slightest change in electric fields. They allow sharks a remarkably acute electroreceptive sense of everything around them. Great white sharks are able to sense electrical fields as small as 125 millionths of a volt. These guys, the bonnethead sharks, are able to detect electrical fields as small as 1 billionth of a volt. And just to put this into perspective for you, imagine I was holding a 1.5 volt battery, one of those batteries that you put into a camera, the teeny ones, and I ran 400 miles of wire from this battery down to Los Angeles. This shark could sense the electrical field off of that battery 400 miles away. So this sense is 5 million times more sensitive than any human sense, and is by far the most sensitive sense we've ever discovered on the planet. So next time you're swimming at the Dolphin Club, you can remember that sharks aren't really smelling you. They're honing in on your electroreceptive field that is coming off of your heart and brain waves. So it was a pretty frightening thought when I learned that, because I surf down at Ocean Beach all the time. So anyway, sharks do it, bees do it, birds do it, we probably do it too. Humans have been using some sort of magnetoreceptive sense for centuries. Ancient Polynesian sailors could navigate hundreds of miles across the open ocean and usually always make it back to the same exact spot. Now, they could use celestial navigation for some of the time, solar navigation for some of that other time, but they couldn't use both all of the time, especially during stormy weather. So how did they do it? Then there's these guys, the Gugu Yamathur, an Australian Aboriginal tribe. They incorporated cardinal directions into their language. They didn't have words for right, left, forward, or backwards, but they did have words for north, south, east, and west. If one of these guys wanted you to make room for him on a bench, he wouldn't ask you to move over to the right, he would ask you to move south. They didn't bend backwards, they bent eastwards or northwards. So the only way this group could communicate was if they knew their exact position on the globe at all times, which is a very hard thing to do at night and a very hard thing to do in an enclosed space. But they weren't alone. Dozens and dozens of cultures also used cardinal languages, just like these guys. The Chechel of central Mexico. They, again, didn't have words for right or left, but they had words for north, south, east, and west. In the 1990s, a bunch of researchers took one of these Chechel speakers and placed him in a room. They blindfolded him, and they spun him around about 25 times, then immediately asked him to identify where north, south, east, and west was. This guy did it without any hesitation 20 times in a row. And I think they just gave up and moved on after that. So, thank God for the 70s. Here's a picture from some 70s experiments. In the 70s and 80s, human magnetoreception was all the rage. They conducted over 1,000 experiments in this stuff, and almost all the time, people who were blindfolded, twisted around, magnets on their head, whatever, they were able to point in their home direction, with one exception. When the experimenters would tape a little piece of magnetite to their foreheads, they lost all sense of direction. Now, researchers had done this years before. They had taken a turtle and they had taken a bird and taped, I'm not talking about a kitchen magnet, I'm talking about a teeny, teeny piece. And it's really sad if you ever see these videos, because turtles just kind of swim in circles lazily. They have no idea how to make their way around. So something was interesting I saw a couple days ago, that the Nobel Prize in Science just went to some researchers that identified something called the internal GPS within cells. These cells are able to activate and stay activated only when an animal is facing in one particular direction, which is how we're able to find our way around and remember where we've gone. We don't know if these cells are magnetoreceptive yet, but it makes sense that they would be. They're doing more research in that. So I know what you're thinking is like, it seems impossible that we would have this sense when we can't find our way out of a shopping mall or a parking lot. The fact is, we just don't need it today too much, but we did need it about 400 years ago and before then. This is what Manhattan was supposed to look like about 400 years ago. You'd need a pretty good sense of direction to make it through here, and especially through the heavily forested areas. This is what Manhattan looks like now. You need zero sense of direction to make it around here. The pattern of settlements, roads, and other landmarks that undergird our modern society make it easy to know exactly where we are. And of course, if ever we're in doubt, you pull out your phone, and from practically anywhere on the planet, you can see exactly where you are through GPS. So our keen sense of magnetoreception has probably become latent and mostly dormant, just like our need to free dive to the seafloor and grab food. But that doesn't mean it's gone away. It's probably easy to revive it if you really want to. You just close your eyes, let your body do the rest. The last thing I'm going to talk about is echolocation. This is not so much an extrasensory ability as it is a very acute sense of hearing. Now, dolphins and whales use echolocation to see with sound better than we can see with our eyes. A dolphin can sense a rice grain from 230 feet away with echolocation. And a sperm whale can see a human in water from a mile away. Echolocation is so powerful in these animals that it can penetrate through flesh and give them a view into what's inside of the things around them. They essentially have X-ray vision. And this is just an animation of a sperm whale using echolocation and looking at everything around him. Now, we're not that good at echolocation, but we are pretty good. This guy is Brian Bushway. He's completely blind. He lost his eyesight when he was 14 years old. I'm not talking legally blind. He has 0 optic nerves. He can't see. But he has taught himself echolocation, the same echolocation that whales and dolphins and even bats use to see in his surroundings. He is able to ride his bike through busy city streets by clicking and listening for the echoes of those clicks and processing where everything is around him. He goes camping alone in the woods for weeks at a time. When I was with him, he could tell the difference between a tennis ball and a Rubik's Cube from across a dining room table just by clicking. When researchers took Bushway and some other human echolocators and put them in an fMRI and it looked at their brains as they echolocated, they found that the visual cortex started lighting up. To the researchers, there was no difference from what Bushway and the other human echolocators were seeing with sounds as it is what we were seeing with our eyes. So different frequencies, they were just processing them in the same way. So we're pretty good, but we're nowhere near as good as the sperm whale. The clicks that human echolocators emit are about 60 decibels. The sperm whale can click at about 236 decibels. It's the loudest animal on the planet. Sperm whales can hear each other in the ocean from hundreds, even thousands of miles away. Some researchers believe that they're able to keep in contact with one another through these clicks on other sides of the planet. These clicks are so powerful in the water that they can blow out your eardrums easily and they can actually vibrate a human body to death. So when you're diving with them, it's a little sketchy. What I'm going to show you now is a video of some freedivers that I ended up hanging out with. I wasn't with them during this expedition, but I was. About 6 months later, we went on a trip together, and I had the same experience. So the clicks you're going to be hearing are not coming from a boat. They aren't coming from a camera. These are the whales clicking these guys literally from the inside out to see what they're all about. And the clicks were so powerful that one of these guys put out his hand to stop a whale from running into him, and his hand actually was paralyzed for about 4 hours afterwards. So he learned not to keep out his hand in front of him when he was diving. This is an emerging discipline of research, and it's pretty sketchy. But this is what it's like. I'm not going to talk over this. We're going to play this kind of loud so you can really get an experience of what this is all about. There we go. Okay. So you're going to notice the whale's going to flip on its belly. That's where it collects those echoes underneath its jaw. They don't use ears underwater. So he's getting a really good look at him right now. He's diving down now. Okay, so I know what you're thinking. Why the hell would anyone want to do that? I know that was pretty loud for all of us, but trust me, in the water, it's like 4 million times louder. And once you're hanging out with the whales for a long time, this didn't happen to me, but it happened to these guys, their bodies started heating up from being pelleted with all of that energy after a while. Again, this is pretty sketchy stuff. It's strange to do. But it's important to note that these guys are fascinated by whales. They don't necessarily want to free dive with them this closely, but they have to, because it turns out the only way to really study these animals up close is by free diving with them, by approaching them in your natural form and interacting with them in that way. Scuba doesn't work. It's too loud. Submarines don't work. Same thing. Robots don't work. They freak them out. But when you free dive with them, this amazing paradigm shift occurs. And they not only don't swim away, but most of the time the whales will turn around and welcome you into the pod. And sometimes they orient themselves vertically and do this very weird sort of new age thing around you as they're clicking. It's extremely intense. So the next question you're probably asking yourself is like, why research sperm whales? Well, it turns out that those clicks you heard, they aren't just used for echolocation. Sperm whales and dolphins also use clicks for communication. And inside of those clicks is probably one of the most sophisticated forms of communication we've discovered on the planet. Could be more sophisticated than human language. Now, I know that sounds completely nuts to all of you, and it certainly sounded nuts to me when I first started researching this stuff a couple of years ago. But just consider a couple things. The sperm whale brain is about 6 times the size of ours. This is a picture of sperm whales facing us head on, and that top thing is their nose, and behind that is their brain. Now, sperm whales also have a neocortex. In humans, the neocortex is believed to govern higher level functions like conscious thought, future planning, and language. Well, sperm whales not only have a neocortex, but theirs is about 6 times the size of ours. Sperm whales also have spindle cells. These are long and highly developed brain structures that neurologists have associated with compassion, love, suffering, and you guessed it, speech. All of those things that make humans human and separate us from great apes. Well, sperm whales not only have spindle cells, but have them in a far larger quantity than we do, and they've had them for 15 million years longer than we have. So why do they have such an evolved brain? Why do they have a neocortex? Why do they have spindle cells? What are they doing when they float side by side and communicate with each other back and forth like this? Again, these aren't echolocation clicks. These are communication clicks. And when you free dive with them, they first pepper you with echolocation clicks, and then they start sending you communication clicks. They are trying to contact us in some way. We know they're talking, we just don't know what they're saying. But hopefully in the next few years of freediving marine research, we just might. All of this sounded pretty nuts to me a couple of years ago when I first met these guys. But after seeing it myself and seeing the data they were collecting, I realized this may actually be an attainable goal to try to make contact with these animals. The reality is now I don't think we really have time to doubt these kind of bold, brave, outlier groups doing this kind of research. The fact of the matter is we're running out of time. The ocean is changing. The seas are rising. 90% of coral reefs in the Caribbean are dead, and they're not coming back. I heard that about 50% of the Great Barrier Reef is dead, and it's probably not coming back. 100 million sharks are killed every year. Their stocks probably aren't coming back. So environmental hazards on the open sea like oil spills, trash, sound pollution, nuclear waste, all of this or some of this is killing whales and dolphins and species we don't even know about yet. So these animals may be gone before we have a chance to fully grasp their amazing abilities. And whatever we learn about them will lead us inevitably back to ourselves. Over the past couple years of freediving with these researchers, freediving with these animals, learning about my body's own amphibious reflexes and magnetoreception and echolocation, it's become clear to me that we don't quite know what we are yet and what our potential is. We don't know what we've come from, what we are now, or what we'll evolve to in the next 10,000 years. So applying the many mysteries still untapped below the ocean surface seems like a pretty good place to start looking for answers. Thank you very much for coming down tonight. Appreciate it.
A couple of questions I wanted to start off with are, so I think of this story as you came in as a skeptic and went native, kind of, in a way, right? I mean, so you didn't know what you were getting into. Were you a diver beforehand? Just had you done scuba diving?
I had done scuba diving. I have been next to the ocean my whole life, so I've been surfing forever. I've been swimming in the ocean forever, but I've spent all of my time at the surface. I never really bothered to look below that. So this was my first foray into that underwater world. Yeah.
And what was it like on your skeptical journey, on your journalist journey, to see these things that seemed like they weren't real, and what was the most challenging to actually accept? I mean, did you quickly kind of convert to, well, I guess all these things are real, or were there things that were harder for you to accept, and what evidence convinced you?
Well, you can only listen to people talking about these experiences for so long, and you can only take what they're saying with, a certain grain of salt. You want to believe them, but you also want to experience it yourself. So I had no intention of freediving when I first started this research. I just wanted to write about these guys, write about their research, and to sort of see the science and what they were doing. But it became very obvious very quickly that if I was ever going to truly understand what they were doing, if I was ever going to truly understand some of the things they were talking about, I had to get in the water with them. And so that's kind of one thing led to the other, and I ended up becoming a freediver and learning how to do this along with them. And but also you see something like that whale footage, and it makes you a little apprehensive. Sperm whales have 8-inch long teeth. They usually eat 60-foot long squid, so they could chomp us like in a millisecond, but they don't. And that was really interesting to ponder why they aren't eating us, why they're communicating with us.
And how long did it take to learn freediving? What was that
It
process?
took me forever because I had been exposed to freediving through only competitive diving. So at Greece, I was mystified seeing someone dive down 300 feet, but I saw a guy go into cardiac arrest, not make it up to the surface. I saw people come up with blood all over their faces. I thought it was the most insane and ridiculous sport I'd ever seen in my life. But luckily, while I was there, I met all of these guys, much more philosophical, spiritual, science-based researchers who are using freediving to apply something else other than a competition, who are using it for science and for a greater good. And that's who I ended up hanging out with and spending all my time with.
So there's a little bit of "don't try this at home" involved. It takes some.
Well, these competitive guys, they will dive past the point where their body tells them to stop. Freediving is it's very common sense. Your body lets you know. It has various triggers that let you know, hey, maybe you should get up and grab a breath of air. In competitive diving, you learn to turn those natural triggers off, which by nature is very dangerous. So I listen to those, and any reasonable freediver is going to listen to those. And in that regard, if you do this responsibly, and if you don't take it as a competition, but understand it as more of a meditation or a yogic practice, it can be a very safe thing. Never do it alone. Always do it with someone. So.
All right, let's. Who's got a question out there on the stairs?
Shallow water blackout?
Yes.
What was the question? Sorry.
Shallow water blackout.
The question is, I've actually known people who died from it. Why is it that shallow...
Oh, okay. So what is shallow water blackout? Okay. What happens when you go deeper and deeper in the water, your lungs shrink. Well, they reinflate as you come back up, but there isn't enough oxygen in your blood to pull from your blood and reinflate the lungs, so it creates a vacuum within your lungs, within your chest. And there's a reason why Neri expelled all of his air at around 12 feet. That's when the greatest pressure happens in the ocean. And so you have to expel all your air at that time. Shallow water blackout is a serious danger to people who push beyond their boundaries. And it can happen to anyone if you keep pushing over and over. The physics of it are very complicated. Those are the basics of what happens in a shallow water blackout. But that's another reason why you never, ever free dive alone. 99% of blackouts in free diving, which are rare in recreational diving, happen within about 5 to 7 feet of the surface. If you have someone there, they grab you, take you up, you're going to be just fine. If you don't, then you can be in serious trouble. So it is a danger, and that's why I don't feel like I should be speaking about the 20 different things you should be doing before freediving. Take a course with an experienced person if you want to do this, and learn all the safety first.
And how common is it? I mean, are there courses around here? I mean, is this
there's becoming like a lot of courses are starting up, mostly in San Diego, where you can do this stuff. A lot of people ab dive. And you hear about how dangerous ab diving is. It's because these people have never taken a course in free diving. They don't know what they're getting
what
into.
is it?
Abalone diving. Sorry, abalone. It has nothing to do with your abdomen. Maybe there is something called ab diving,
actually,
downtown, but I don't know about it.
Another question, back there.
With all of these capacities atrophying in modern times, are you at all concerned that they're not going to be genetically conserved into the future, and does it even matter, or now that we've typed, it doesn't?
Well, I think it's only been until very recently that we haven't needed to use diving. You look at cultures around the world, and every culture that was by the ocean was free diving, almost every culture. I mean, even up into the Baltic Sea, there's evidence of free diving cultures that dates back 10,000 years. So, it's just in the last about 100 years that we've developed fishing technologies that have made free diving obsolete. Up until around 50 years ago, there were still many Japanese ama divers diving and Greek sponge divers. My understanding of how genetics works is it's going to take thousands and thousands and thousands of years. Also with echolocation, this is something, I took a course, a little 30-minute course with Brian Bushway, and was able to easily tell the difference between wood and glass and plaster and corners. I mean, it just clicks on very, very quickly. So I think we're a long way off from forgetting all these things.
And as far as kind of the evolutionary biology and the developmental line of this, has that connection been made before that, hey, we can survive, we can handle going to these depths because we're in liquid, that's like the ocean in the womb kind of thing? Is that something that you found sources that had already kind of made that connection, or is that something?
I think, yeah, there's been a lot of research into mammalian dive reflex. They've been researching it since the 50s, and they found it in so many other animals. And right now, they're doing a lot of research with humans, because these scientists will say, the deepest we could possibly go is 500 feet. And someone dives to 600 feet, and they're like, oh man, okay, the deepest we can possibly go is 650 feet. And then I saw a guy dive to 800 feet. So we keep reprising this because we just don't know the human body's potential in water yet. We're not even close to understanding it. So this isn't something, to answer your question, this isn't something I made up. There's a long line of research that many people are doing at this time.
So the subheading of your book is Renegade Science, right?
That's right.
So talk for a minute about how it's a renegade, what the scientific establishment is. There's clearly some tension between the establishment and these guys.
Yeah, one of the main guys I write about, his name is Fabrice Schnoller, and he was sailing out off the coast of Mauritius about 7 years ago, and he saw some whales and didn't know anything about whales, so he hopped in the water and he heard that clicking, and he thought it was coming from a motor on the boat. And then he looked down and he noticed there were whales surrounding him, clicking at him, and he stayed in the water for about 4 hours with these animals and just had this, he's this French guy, he's like, mind-blowing, new age experience. So since then, he tried to work with a bunch of, he's probably going to listen to this, so Fabrice, I love you, thank you. But he tried to work with a bunch of universities and a bunch of different researchers, and they just had no interest. So he started his own research group.
And he has a scientific background. What's his
Yes,
background?
he has a scientific background. He had a lumber store, and he quit doing that, and he's possessed with trying to figure out these animals. So he's very
He
good.
left lumber behind.
He has left lumber behind, yes. He's very good at collecting data. He's not too good at analyzing it, which is why he's gotten acoustic scientists from the French Navy and all that to help analyze the data. But just very quickly, in the few years that he's been collecting data with freediving, doing this freediving approach, he has more sperm whale and dolphin footage of communication than anyone else on the planet. So that just kind of goes to show you how effective this mode of research is.
And when he first encountered them, he was freediving, or he was just, it sounded like you said he was just kind of at the surface? Or?
He was at the surface, but something amazing happens. Like they're cool with you when you're snorkeling with them, but they get really excited when you're able to dive down about 50 feet and interact with them down there. And that's when they really stick around.
And you said that if somebody goes down with scuba gear or robots, they respond very negatively. Right?
Scuba is very disruptive to them, and it's very loud. And so usually they're not going to stick around almost all of the time. They're not. But freediving, almost all of the time, they see you, they're going to turn around and interact with you.
There's another one back there. Sorry, no. Okay, I'll go with you.
Are there any advantages to using closed-loop rebreathers for kind of communication?
Yeah, rebreathers are great, and there's a lot of new technology with them right now. The problem is when you're on these research expeditions, it looks like, man, you just go out to the ocean, you just dive with these whales. Like, I want to do it. You don't know, the real story is like 10 days in a row on a teeny boat with 8 other people in the sun without shade looking for whales. So when it happens, when you see them, you have to act very quickly. You've got to put on your mask and get in the water immediately. So rebreathers take a long time to prepare. There's a lot of little things that can go wrong, and they can be really dangerous if you're not meticulous,
And how do they work?
meticulous about it.
Can you just give a short explanation with
A
rebreathers?
rebreather will clean the carbon dioxide out of the air and will create more oxygen. So it's essentially like a scuba tank, but it's a closed system. You
So
can keep
a
using it.
freediver using that are they able to be combined, or is that just?
You wouldn't need to if you had a rebreather.
Okay.
You could keep exhaling and inhaling, no problem. It's just they're quite large. They're a little cumbersome. They're hard to take to very strange places, and you need to be, very quick. But there are some photographers. Some of these shots were shot by a guy who uses a rebreather. So,
Yeah, right there.
So, some of what you discussed makes it sound as though there are benefits similar to, like in the rewilding movement, not to be confused with the de-extinction movement, but in the spirit of reconnecting with nature to reinvigorate these parts of ourselves that have been latent for a while, genetically or otherwise. At the same time, beyond personal benefits, it sounds as though, you call it renegade science, which makes me think of citizen science. So I guess my question is, if you're inspiring people here to take up freediving, is there any way that our observations can be taken seriously by the scientific community, or is it just not there yet?
a really good question.
So how do you do citizen science and crowdsource towards the science that's going on that you're talking about in this book?
Renegade and citizen science, totally interchangeable. We thought renegade science sounded better for the book title, so we use that. But he's essentially a citizen scientist doing this. What's enabled him to do all of this stuff is because technology is so cheap right now. He's making all of his own rigs out of stuff he buys off of eBay. 10 years ago, even 5 years ago, a lot of this wouldn't be possible. So he is trying to incorporate many other citizen freediving scientists to contribute towards this research. His site is darwin.org, and you can look it up online and see what he's doing. He's always looking for volunteers. So what he's doing is trying to find a rig or produce a rig that anyone can wear that will be able to record these clicks in a certain way that scientists can actually use them.
And would you say his next step is publicizing it, getting things out in the media, or is it publishing research or making a connection into a more formal research kind of setup? What's his goal right now?
Absolutely. Everything's going to be peer-reviewed. That's what the actual researchers at the University of Paris are doing right now. they're making sure all of this stuff is bulletproof because it's so insane. So before he really comes out, right now they're just researching, trying to establish the software, get all the hardware set up, and just to collect more data.
And his focus is predominantly on the whales themselves, not on the human aspects of it. I mean, are there, because clearly this is pushing boundaries as far as what we understand about how humans can go underwater, but is that pretty much mostly in terms of the extent to which we can stay under?
He just uses freediving casually as a tool. Right. It's an effective tool, and that's it. There are other people pushing boundaries at the Karolinska Institute. They're doing a lot of research into the mammalian dive reflex. There's one guy who has developed this new way of freediving on empty lungs. So if you think it's hard to dive with a breath of air, imagine doing it with no air at all in you. He says that this allows you to go deeper because you don't have that exchange of, I tried it once and it sucked, so probably not gonna do it. So there are people doing a bunch of research into the mammalian dive reflex.
We should go one slide further and get your book cover on that. There we go. So the book's been out, you said about 3 months?
About 3 months, yeah.
How long did it take to write it, and is it the book you thought you were? I mean, did you start this process at where you were at in this process? You're like, okay, I need to write this book about freediving and about what?
Not at all. I had no intention of writing a book about freediving or whales or dolphins or any of that. But after Greece, I remember talking to my agent and said, oh, there might be a book here. And we were able to sell the nonfiction book. And of course, the publisher got excited and wanted a 1-year turnaround. I don't know if you know too much about nonfiction book writing, but it usually takes 3 or 4 years. And I was very arrogant. I said, well, of course, no problem. And
I could do it while holding my breath.
Watch this. So it took 18 months, and 9 months of that was spent traveling. So I've been catching up on sleep ever since then. So it was a very quick 1.5-year book from start to finish till when it was delivered. And it's been out for about 3 months, yeah.
Is there any more besides what you touched on in the talk about the magnetic sense in humans? Is that something?
There's a lot more, but I didn't want to totally bore everyone with the specifics. There's a lot more in the book as well. They found, well, I'll just give you one little piece. So about 2 years ago, researchers found a protein in the human eye called the H-Cry2 protein that is magnetoreceptive. And from that, they were saying this has probably been used for years and years and years to help us orient towards magnetic north. What happens when the polar shift happens, comes, and that's when magnetic north will shift to magnetic south. Who knows? It might mean broad extinction for everyone who has magnetoreception, but I guess we'll have to wait and see.
So was anyone here for our endangered language talk that we had? A lot of our staff. And a few of you. So actually, I think there were 2 topics here. Some of the clicking languages, which is, I don't know if we've confirmed there's a direct connection with the echolocation, but certainly there's some suggestions of that. And then the cardinal languages, which in another talk in this series we talked about. Let's have one last question. Is there somebody who's read the book that's got a question? Right there. Okay. There we go. There's the last one.
Book is awesome. Absolutely love it.
Thanks.
And the title Renegade Science actually recalls something you talk about in the book, which is John Lilly's research back in the 60s, I think it was. And you revealed some crazy stuff there. And I'm just wondering, with FOIA requests, the ability for freedom of information, et cetera, where did all that data go? Tell us about the data. Tell us where it went. What's going on with it?
Well,
Who's John Lilly and
Sure, I'll try to recap this very quickly. It's a very long story. John Lilly was a neurophysiologist at the National Institute of Mental Health that created something called the sensory deprivation tank. Now it's been rebranded as the float tank because that sounds better. So he got very interested in dolphins. He was convinced they knew how to talk and ran a battery of amazing tests with the Navy. And one test, they claim to have deciphered and translated 242 words of dolphin whistle into English and then back again. And then it gets very weird. A bunch of conspiracy theorists come in. The guy who did this, a lot of this work with Lilly, was a Harvard scientist, suddenly died, and the reports went missing forever. And then Lilly got really into LSD and started shooting dolphins up with LSD and trying to have dolphin English language immersion workshops, which totally worked.
Totally.
So they worked, and then he got so depressed. He knew how intelligent these animals were. Their brains are bigger than ours. He got so depressed that he let all the dolphins free and said, I'm never going to do this again. And he, at that time, completely destroyed the field of interspecies communication with all of his research. And it took about 35 to 40 years for it to come back. And it's just barely scraping back, but it's all under the pall of Lilly shooting up dolphins with LSD and holding dolphin immersion language workshops. So these legitimate researchers are just having to constantly fight against this new age storm that seems to push in from all directions to do real legitimate science in dolphin communication.
All right, well, that's an amazing place to end this. So thank you, everyone. You've been a fantastic audience. Let's have one more round of applause for James.
Thanks a lot.